Hello everyone, welcome back to my channel. Today I'm going to discuss the heat round exam for TIMO 2017 to 2018. I'm going to do primary 2 level, and this is the complete exam during the heat round. The heat round is the first round or the qualifying round. Before I start, please support my channel by subscribing, and so that you may also be updated of my upcoming or new videos or tutorials for TIMO or HKIMO or any mathematical Olympiad exams. Okay, so please subscribe and hit the bell button to be updated. Now let's get started. For logical thinking part, problem number 1. Given Amy has 3 sisters and 2 brothers, how many children does Amy's mother have? So, Amy is a girl, so she's among the 3 sisters, and plus the 2 brothers, so the answer of this is, Amy has 3 sisters, so plus 2 brothers, so she has 5 siblings. And then including herself, that's 6. So there are 6 children. Number 2, according to the pattern shown below, what is the 27th symbol counting from the left? Counting from the left, it looks like the pattern here is 1 circle, 1 triangle, 1 square, and then 2 circles, 2 triangles, 2 squares, and then 3, 3, 3, and the pattern continues. So we are going to find the 27th pattern. To do that, first with one shape, it's one triangle or 1 circle, 1 square each, that is 3. And then if we double each figure, that's 6. So plus 6. If we triple each figure, that's 9. And then if we get 4 for each figure, that's 12. And this one sums up to 30. So if we continue this pattern, in the 4th group, there will be 3 circles, 3 triangles, and 3 squares. And the last figure of that is the 30th figure. So the last group will be 4 circles, 4 triangles, and 4 squares. And then this is the 30th, so this is the 29th, this is the 28th. So the 27th is a square. So the answer for this problem is a square. Number 3, after 6 years, Amy will be 13 years old. How old was Amy 4 years ago? So 6 years from now, Amy will be 13. It means Amy now is 7 years old. 4 years ago, 7 minus 4 is 3. So the answer of this is 3. Problem number 4. John wrote a 2-digit number on a piece of paper and asked Peter to guess it. Peter asked, "Is the number 89? John replied, "One of the digits is correct. The position of that digit is also correct." Peter asked again, "Is the number 17? John replied, "One of the digits is correct. The position of that digit is wrong." Peter asked again, "Is the number 75? John said, "One of the digits is correct. The position of that digit is also correct. What is the number written by John?" So, in the first part, when Peter asked, "Is it 89? So, John said, one of the 2 numbers is correct. The position is also correct. So we are already having an idea that the either the 10th digit of that number is 8 or the units digit is 9. So these are the two possible numbers or digits with correct position. Then the second part, is it 17? John answered, one of the digits is correct, but the position is wrong. It means if the position is wrong, we swap their position. So their correct position, the correct position of one of the correct numbers or correct digit must be like this, 7 and 1. So either the number is 7 in the 10th digit or 1 in the units digit. 10th digit 7, 1's digit 1. And lastly is the number 75. John answered, one of the digits is correct and the position of the digit is also correct. So 75, one of the digit is correct, the position is also correct. From here, we can deduce that the number in the 10th digit is 7. So it must be 7. And from the first condition, first part, the units digit must be 9. Okay, so the answer for this problem is 79. So the 2-digit number is 79. Okay, problem number 5. According to the pattern shown below, how many X symbol is or are there in the 10th group? So by looking at this, in the first group there's 1 of that symbol. In the second group there are 9. In the third group there are how many? There are 17. Again, let me write it again. In the first group, there's 1 of that symbol. Second group, 9. Third group, that's 17. So in the question is, in the 10th group, how many of this kind of symbol must be in the figure? So to solve this problem, we need to find a pattern based on these numbers 1, 9, and 17. So it looks like the pattern here is this one is 0 times 4 plus 1. This one is 2 times 4 plus 1, and this one is 4 times 4 plus 1. Okay, so how did I get the 0, 2, and 4? I get that by here there's 1 minus 1, 0. Here there are 3 minus 1, that's 2. So that's why I get 2 here. And here there are 5 minus 1, that's 4. Okay, so this is my formula. 0 times 4 plus 1 for the first group. Second group, 2 times 4 plus 1. And the third group is 4 times 4 plus 1. So 0, 2, 4. So we are looking for the 10th group. So first group uses 0, second group 2, third 4, 6, 8, 10, 12, 14, 16, 18. The 10th group must start with 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in the 10th group, there must be 18 times 4 plus 1 of that symbol. And that is equal to 73. Okay, so the answer for this problem, how many of that symbol in the 10th group? The answer is 73, or 18 times 4 plus 1. Okay, let's go to the next problem, number 6, for the arithmetic part. Find the value of 1 plus 3 plus 5 and so on. So this is simple addition. So you can easily do it by yourself. The answer of it is 100. Number 7, find the value of 15 times 12 plus 15 times 3 minus 15 times 5. So for every pair, common factor is 15. So we can rewrite it. We can rewrite the expression as 15 times 12 plus 3 minus 5. And that is equal to 15 times 10, or 150. The answer is 150. Number 8, find the value of 2 minus 4 plus 6 minus 8 plus 10 minus 12 plus 14 minus 16 plus 18. So for number 8, we can rewrite it as, we can start from the last. Number 18 minus 16, that's 2. 14 minus 12, that's 2. That's 2, that's 2, that's 2. So this is the difference, or the sum here is 2. Here that's 2, so that's 4. Another 2, so 6. Another 2 is 8. Plus the 2. So the answer of that is 10. Number 9, what is the number that should be filled in the blank if the equation below is correct? So this is simply 861 divided by 123. And what is 861 divided by 123? 7. So the answer on the blank space must be 7. Number 10, if A and B are both one-digit numbers, what is the value of B if the equation is correct? So what is the number that satisfies this equation? That we're going to get a two-digit number with units digit 0. So this number here could be 10, 20, 30, 40, 50, 60, 70, 80, or 90. It looks like our A must be 5, because that would be 55 plus 55 equals 0, equals 60. So A is 5, B is 6. So moving back to the problem, what is the value of B? The answer is 6. Now let's go to the next part. Problem number 11. If Amy has 118 apples and John has 22 apples, how many apples does Amy have to give John to make them have the same number of apples? So to get the same number of apples, we're going to add all their apples. 118 plus 118 plus 22, that's 140. And then we are going to divide that equally into 2, and that is 70. So in order for Amy to have 70 apples and John have 70, so we will subtract 70 from 118, and we get 48. It means Amy must give 48 to John, okay, so that each of them will get 70 apples. Number 12, 4 students have 30 balloons in total, and each of them has a different number of balloons. At least how many balloons does the student with the most balloon have? So how do you get 30? Using 3 different numbers. Example of that could be, how do we get 30? Example of that could be 5, 6, 7. What is 5 plus 6, 7? That is 18. So 12. Okay, that's 30. That's one way, but the question here is, what is the least or the least number of balloons? So the minimum number for this here, the maximum. I mean the biggest number, what is the minimum here? So the minimum here must be what? it should be 9. Okay, why is it 9? Because we can have our equation as 6 plus 7 plus 8 plus 9 equals 30. So the least number of balloons for the student that has the most balloons is 9. Okay, the answer is 9. Okay, there you can't have less than 9 here for this position. So the least number of balloons for the one with the most number of balloons is 9. Number 13, the numbers below follow the arithmetic sequence. What is the 10th number? 21, 33, 45, 57, 69. It looks like this is an arithmetic sequence and the pattern is plus 12, plus 12, plus 12. Okay, so we're looking for the 10th number. So the solution of this will be, so starting from the first number 21, we're going to add 12 9 times in order to get the 10th number. So starting from the first number 21, you add 12 each time, right? So that's plus 12, plus 12, plus 12, plus 12. In order to get the 10th number, you will be adding 12 9 times. So that's 12 times 9. And what is 21 times, okay, that is 21 times 12 plus 9. Or what is 12 plus 9? 108. 108 plus 21, 129. The answer for this problem is 129. Next, number 14. How many 3-digit even numbers that are multiples of 5 is or are there? 3-digit even numbers that are multiples of 5. First, multiples of 5 are numbers that end with 5 or 0. But if it ends with 5, it's not an even number. It means we're looking only here for 3-digit even numbers or numbers that end with 0. So 3-digit numbers that end with 0. So starting with hundreds, so the numbers are 100, 110, up to 190, and that is 10 numbers. That also applies for 200 to 290, up to 900 to 990. So each group has 10 numbers. So that's how many groups? 100 groups, 200 up to 900. That's 9 groups. So 9 times 10 is 90. So there are 90 3-digit numbers, 3-digit even numbers that are multiples of 5. Okay. Next problem, number 15. What is the largest 2-digit number that is divisible by 3 and 5? So the numbers that are both divisible by 3 and 5 are those that are divisible by 15. And what are the 2-digit numbers that are divisible by 15 or multiples of 15? Those are 15, 30, 45, 60, 75, 90. So what is the largest among these numbers? 90. So the largest 2-digit number that is divisible by 3 and 5 is 90. Problem number 16. How many squares are there in the figure below? So this is simple counting. So those with one square units is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 16. And then with 4 squares, that's 1, 2, 3, 4, 5, 6, 7, 8. So 16 plus 8, 24. And the squares with 9 square units is this 1, 2. So 24 plus 2 is 26. So the answer for this problem is 26. Again, how did we get 26? So how many squares? Those with 1 square unit are 16 of them. Those with 4 square units is 8. Those with 9 square units is 2. So total is 26. Number 17. A prism has 17. A prism has 7 faces. How many vertices does the prism have? So a prism has 2 bases. So if we remove the upper base and lower base, then the number of faces will be minus 2. Okay, so 7 minus 2, it means 5. So the base of this prism must have 5 sides. So it should be a pentagon. So the prism must have a pentagon base. Okay, again, 7 faces. So if we remove the 2 faces, which are the bases, the top base and the bottom base, we are left with 7 faces. And this we are left with 5, and this 5 is the lateral faces. So there are 5 lateral faces. It means the base of this prism has 5 sides. So if it has 5 sides, it has 5 vertices also for each base. And there are 2 bases, so 5 times 2, 10. So the answer for this problem is 10. It would look like this. So the base is a pentagon. Okay, remove the upper base and lower base. So upper face and lower face, the top face and bottom face. So you are from 7 faces, you are left with 5 faces. These 5 faces are the lateral or the sides. And then since there are 5 sides, it means the base is a pentagon. So the pentagon has 5 vertices. So 5 vertices here. 1, 2, 3, 4, 5. 5 also here. 1, 2, 3, 4, 5. So 5 times 2, 10. The answer is 10. Number 18. At most, how many right angles could a triangle contain? A triangle could only contain at most 1 right. Only 1 right triangle. It cannot have more than 1 right because the sum must be equal to 180. If you have 290 already, that's already 180. So that's only 2 angles. So that cannot be. So the maximum number of right angles in any triangle is 1. Number 19. At least how many squares can be seen if viewing the figure below? From the top view of this will be, you will see this square, or this cube, this cube, this cube, this cube, this cube. That's 5 cubes. So the answer of this is 5. So you can see 5 cubes if you view this figure from the top. Now, number 20. At most, how many triangles can be formed by drawing 4 straight lines on a plane? Drawing 4 straight lines on a plane. If we do like this, we can only get 1, 2, 3 triangles. But if we do it like this, we will have 4 triangles. 1, 2, 3. 1, 2, 3, 4. So the maximum number of triangles we can draw using 4 straight lines is 4. The answer of that is 4. Number 21. After Amy gives 4 apples to Andy and 5 apples to Johnny, they will have equal number of apples. How many apples did Amy have more than Andy originally? So let's illustrate this problem. So this is Amy, this is Andy, and this is Johnny. So after Again, after Amy gives 4 apples to Andy and 5 apples to Johnny, they will have equal number of apples. How many apples did Amy have more than Andy originally? So after Amy gives 4 to Andy and 4 to Johnny, 5 to Johnny, so Amy will have -4 and -5. They now have equal number of apples. So Amy gives 4 to Andy, so +4 for Andy, so -4 for Amy, and gives 5 to Johnny, so +5 for Johnny and -5 for Amy. And they have now equal number of apples. So for me, I will solve this like letting the number of apples of Johnny be originally 0. So Johnny has 0 apples at first because Johnny now has the most number of apples. So let be the number of his apples be 0 at first. So originally be 0. So in order for this to be equal to that 0 plus 5 is 5. In order for this to be equal to 5, we let Amy have 1 apple originally. So Johnny has 0 apples at first. Andy has 1. And how do you make it equal to 5? We should have here 14. So 14 minus 4 minus 5, that's 5 also. So all of them now have 5 apples. 5, 5, 5. So originally Amy has 14, Andy has 1, Johnny has no apples. So the question is originally how many apples did Amy have more than Andy? So if with this scenario, Amy has 14, Andy has 1, so she has 13 more. So the answer is 13. Number 22. Choose 2 digits without repetition from 2, 3, 4, 5, 6 to form 2-digit numbers. How many even numbers is or are there? So if we're going to choose 2-digit numbers, those numbers are those that end with even, right? 2-digit even numbers. So those that end with 2, so that is 32, 42, 52, and 62. And those that end with 4, that is 24, 34, 54, and 64. Those that end with 6, so that is 26, 36, 46, 56. That's a total of 12. So the answer is 12. There are 12 2-digit even numbers that can be formed using the numbers 2, 3, 4, 5, and 6. 12 is the answer. Number 23. There are 2 ways from the market to the train station. There are 5 ways from the train station to the cinema. There are 4 ways from the cinema to the library. How many different ways are there from the market to the library, through the train station and cinema? So we just simply multiply the number of ways from market to train station. That's 2 ways, and then market to train station 2 ways, and then train station to cinema 5 ways, and then cinema to library 4 ways. So that is 2 times 5 times 4. So the answer is 40. There are 40 ways. Okay. Next problem, 24. What is the smallest 5-digit number using 0, 1, 2, 3, 4? Okay, the smallest 5-digit number here will start with 1, and then the next is 0, and then 2, 3, 4. So 1, 0, 2, 3, 4, or 10,234 is the answer for this problem. Last problem, Peter has 7 $1 coins, 2 $2 coins, and 1 $5 coin. How many ways can he buy for a souvenir costed $7 without any changes? So how do you get the 7 using these coins? How do you get $7? First, we will use the $5 coin. There's only one $5 coin, so that's 5 plus, you may have $1 and $1, so that's 7, or 5 plus $2, that's 7. Or next, if we use the $2 coins, we can have 2, 2, 2, 2, and then plus 1, so that's 7. Or you can have, sorry, this cannot be because there are only two $2 coins, so this must be 1 and 1. So 2 plus 2 plus 1 plus 1 plus 1. Or we can use one $2 coin, and the rest will be 1, 1, 1, 1, and 1. So that's also 7. And the last is if all are $1 coins. 1, 2, 3, 4, 5, 6, and 7. So there are 5 ways for this problem. 5 ways to buy a souvenir without any change using these coins. Okay, thank you so much for watching. Please subscribe so that you will be updated for more practice exams. More tutorials for the previous exams for TIMO or Thailand International Mathematical Olympiad. See you next time. Bye-bye.